The automotive industry is all in on battery power. There are still many ways the industry can push battery technology to allow drivers to go further, to create greater safety, and ultimately increase the value of their vehicles. At Electra Vehicles, we are focused on utilizing a unique approach to maximize the performance and lifetime of batteries in electric vehicles. With proprietary software installed both in the electric vehicle's battery pack and deployed in the cloud, we can take a new hybrid approach to creating a higher performing vehicle utilizing a 360 degrees of data input from the battery, the driver, the surrounding environment, and the vehicle, to retrain the battery management system using artificial intelligence and machine learning.
When we started this project, our main objective was to prove that our adaptive cell modeling system, the ACMS, can predict the battery state of charge more accurately than the existing solution, namely EKF or Extended Kalman Filter. So how can we demonstrate that our solution can more accurately predict the battery measurements? We first built a battery pack from scratch.
We wanted to focus on a cell type that was fairly commonplace with the electric vehicle industry to best illustrate the outcomes from an EV driver's perspective. LG M50 cells utilize a high nickel NMC 811 cathode, which is key to delivering on its high energy density, roughly 267 Wh per kg. Using a graphite anode and in the 21700 cylindrical format, the cell's makeup is similar to that being used by many of the leading EV OEMs. With the pack constructed, an external circuit connection through a chain of hardware to both the battery cycler and the cloud through the battery management unit and Goldbox IoT gateway was the next set of action items. With the battery connected to the battery management hardware, Electra then deployed both our adaptive cell modeling systems ML model and a traditional extended Kalman filter, also called as EKF, on the battery management unit. We then created a secure connection to Electra's AWS cloud, where the cloud-based ACMS is deployed.
Electra's battery brain now lives on both ends of this chain, in the battery management system and in the cloud. It allows us to pull real-time inputs, import them into the embedded software models, and accurately display the state of the battery, while sending all the data to the cloud to allow us the ability to retrain the embedded models for increased accuracy.
Then we repeatedly charged, discharged, and allowed the battery to rest using a predetermined charging profile and compared the three outputs. First, we have Electra's ACMS reading, second, the EKF, and third, a reference measurement.
Our team ran the cycling experiment for 12 weeks. Over the course of those 12 weeks, we collected an enormous amount of data from the battery through the embedded electronics and then relayed it up into the cloud. During that period of 12 weeks, the battery aged from about 100% health at the beginning to about 90% capacity at the end of those 12 weeks.
The charge, discharge, and rest steps that was used was crafted in a way to push the battery to its limits and age the battery much faster than what would typically happen in an EV driving scenario. We did this because we also wanted to show that we can predict a battery state of charge better than the EKF at the beginning of life and also as the battery ages, which is where we expect to see the divergence increase significantly. This is because the EKF methodology is fixed following those early voltage readings, but as time progresses, those early readings aren't really accurately reflecting the full picture of how the battery has aged through the wear and tear of its very personal usage.
Now, why do we care about improvements in state of charge prediction? We care because that's the foundation to improving the range of batteries, because everybody has problems with range anxiety today and we want to alleviate those problems. And second, we want to make sure that the long-term health of the battery is improved so batteries can last way longer than they do right now. By improving the charge and the health of the battery, we want to ensure that we provide value not just to the OEMs who manufacture these cars and batteries, but to the end customers who use them. This was the first demonstration of a cloud-connected hybrid solution that works both in the cloud and in embedded electronics in the car to give the comprehensive solution that OEMs need for battery management. With the completion of this project, we are happy to report a positive outcome, which came as a result of careful planning, collaborative team effort among our research, engineering, sales, and marketing teams, and confidence in creating a solution that goes way beyond today's industry standard.